The idea that the Earth is flat is not a new one. This belief dates back to ancient civilizations, where early astronomers and philosophers speculated about the nature of our world. It's a belief that has been around for centuries, despite overwhelming scientific evidence to the contrary. From the time of Aristotle to the voyages of Magellan, evidence has consistently supported a spherical Earth. In recent years, however, there seems to be a resurgence of this ancient idea. This revival is not just a fringe movement, but has gained significant traction, especially on social media platforms. This resurgence is likely due to the spread of misinformation on the internet and a growing distrust of authority figures. The digital age has made it easier than ever for conspiracy theories to proliferate and for like-minded individuals to find each other. Professor Brian Cox, a renowned physicist from the University of Manchester, is a vocal critic of the flat Earth theory. He has dedicated a significant portion of his career to public science education. He has spoken out against it on numerous occasions, using his platform to educate the public about the overwhelming evidence that supports a spherical Earth. His efforts include public lectures, television appearances, and social media engagement. Professor Cox, along with other prominent scientists like Neil deGrasse Tyson and Bill Nye, are constantly working to debunk these misconceptions. They use their influence to promote scientific literacy and critical thinking. The persistence of the flat Earth theory is a testament to the power of belief and the human capacity to ignore evidence that contradicts our worldview. It highlights the psychological aspects of belief systems and how they can be resistant to change. It's a stark reminder that we must always be critical of the information we consume and be willing to change our minds when presented with new evidence. Education and open-mindedness are key to combating misinformation and fostering a more scientifically literate society. One of the most fundamental pieces of evidence supporting a spherical Earth is the law of gravity. This invisible force is what keeps us grounded and governs the motion of celestial bodies. Sir Isaac Newton, in his groundbreaking work, laid out the principles of universal gravitation, which revolutionized our understanding of the universe. This law states that every object in the universe attracts every other object with a force proportional to their masses and inversely proportional to the square of the distance between their centers. This means that the gravitational pull between two objects becomes weaker as the distance between them increases. This means that objects with greater mass exert a stronger gravitational pull. For instance, the Earth, being massive, exerts a significant gravitational force that keeps us and everything else anchored to its surface. On a spherical Earth, gravity pulls everything towards the center, regardless of location. This uniform pull is what gives us the sensation of down, no matter where we are on the planet. This is why people on the opposite side of the globe don't fall off. Gravity ensures that everyone, no matter where they are, is pulled towards the Earth's core. If the Earth were flat, gravity would pull everything towards the center of the flat plane. This would create a very different experience of gravity than what we are used to. This would lead to some strange occurrences. For example, the gravitational pull would not be uniform, causing objects to behave unpredictably. For example, objects further away from the center of the flat Earth would experience a weaker gravitational pull. This would mean that the further you move from the center, the less you would feel the force of gravity. This means that walking towards the edge of a flat Earth would feel like walking uphill, as you're fighting against the direction of gravity. The experience would be akin to climbing a steep incline, making everyday activities quite challenging. Professor Cox often uses the example of airplane travel to illustrate the fallacy of the flat Earth theory. He points out that airplanes can fly in one direction and eventually circumnavigate the globe without encountering an edge or falling off. This is only possible on a spherical Earth. If the Earth were flat, as some proponents believe, airplanes would have to constantly adjust their course to avoid flying off the edge. This is simply not the case. The fact that airplanes can fly in a straight line and eventually end up back where they started is a testament to the Earth's curvature. Furthermore, the routes that airplanes take around the globe would be impossible on a flat Earth. For example, flights from South America to Australia often fly over Antarctica. This wouldn't be possible on a flat Earth map, where Antarctica is depicted as a giant ice wall surrounding the perimeter. One of the most common questions asked by flat Earth proponents is, if the Earth is round, why don't we fall off the edge? This question stems from a fundamental misunderstanding of gravity and the nature of a spherical Earth. As previously mentioned, gravity pulls everything towards the center of the Earth. This means that there is no up or down in the grand scheme of the universe, only towards or away from the center of a massive object. On a spherical Earth, down is always towards the center, no matter where you are on the surface. Another argument against the flat Earth theory lies in the observation of stars in the night sky. Different constellations are visible from different parts of the Earth. This wouldn't be possible if the Earth were flat. The curvature of the Earth allows us to see different parts of the sky depending on our location. Section 5. A lack of perspective. The flat Earth theory often relies on a limited perspective, one that doesn't take into account the vastness of our planet. People who believe in a flat Earth often cite their own personal experiences as evidence, claiming that what they see with their own eyes is the ultimate truth. They'll say things like, "The Earth looks flat to me," or "I've never seen the curvature of the Earth," as if their limited viewpoint is enough to disprove centuries of scientific research. While it's true that the Earth appears flat from our limited perspective on the ground, this is simply an illusion caused by the vast scale of the planet. The human eye can only see so far, and the Earth's curvature is subtle over short distances. The Earth is so large that its curvature is not readily apparent to the naked eye at ground level. However, when you gain altitude, such as in an airplane, the curvature becomes more noticeable. There are numerous ways to observe the Earth's curvature without having to go to space. Scientific experiments and observations have consistently demonstrated this curvature. One classic example is the observation of ships disappearing hull first over the horizon. This phenomenon has been noted for centuries and is a clear indication of the Earth's curvature. As a ship sails away from the observer, it gradually disappears from view, with the hull disappearing first and the mast being the last part visible. This is a direct result of the Earth's curved surface. This is because the Earth is curving away from the observer, and the ship is gradually disappearing over that curve. Such observations, when combined with other scientific evidence, provide a comprehensive understanding of our planet's true shape. Section 6. The power of belief. The persistence of the flat Earth theory, despite overwhelming evidence to the contrary, highlights the powerful influence of belief systems. People often hold on to beliefs that provide them with a sense of certainty and control, even when those beliefs are contradicted by evidence. Conspiracy theories, like the flat Earth theory, often thrive on mistrust of authority figures and institutions. Believers often see themselves as a select few who are privy to secret knowledge that the rest of the world is blind to. This can be a powerful motivator for maintaining belief, even in the face of overwhelming evidence to the contrary. It's important to approach such beliefs with empathy and understanding, while also firmly addressing the misinformation that fuels them. Education and critical thinking are crucial tools in combating the spread of misinformation and promoting a greater understanding of the world around us. While it may seem like flat Earth proponents are unwavering in their beliefs, there have been cases of individuals changing their minds when presented with irrefutable evidence. One such case is that of Jeran Campanella, a prominent flat earther who embarked on a journey to Antarctica to prove his beliefs. Campanella, armed with GPS equipment and a documentary crew, set out to measure the distance between 2 points in Antarctica. He believed that his measurements would prove that Antarctica was not a continent but rather a giant ice wall surrounding a flat Earth. However, his experiment backfired. To his surprise, Campanella's measurements confirmed the Earth's curvature. He had inadvertently proven himself wrong. This experience led Campanella to publicly renounce his belief in a flat Earth and acknowledge the overwhelming evidence supporting a spherical Earth. Section 8. The importance of science. The debate surrounding the shape of the Earth highlights the importance of scientific literacy in today's world. In an age of rampant misinformation and disinformation, it's more crucial than ever to be able to critically evaluate information and distinguish between fact and fiction. Science provides us with a framework for understanding the world around us. It's a process of observation, experimentation, and evidence-based reasoning that allows us to make sense of the natural world. By embracing scientific thinking, we can become more informed citizens, better equipped to make decisions that affect ourselves and our communities. The scientific method encourages us to question everything, to seek evidence, and to be open to changing our minds when presented with new information. It's a powerful tool for combating ignorance and promoting a greater understanding of the universe we inhabit. Section 9. The Universe Beyond. The flat Earth theory, while demonstrably false, can serve as a starting point for a broader conversation about the universe and our place in it. By acknowledging the vastness and complexity of the cosmos, we can cultivate a sense of wonder and curiosity about the world around us. From the intricate workings of the human body to the vast expanse of space, there is so much left to discover and explore. By embracing science and critical thinking, we can continue to push the boundaries of human knowledge and unlock the secrets of the universe. The Earth may not be flat, but the possibilities for exploration and discovery are limitless. Let's continue to explore, to question, and to marvel at the wonders of the universe.